So we'll officially begin studying the fundamental concepts of mathematics. We'll be going over statistics first because that has the most utility in machine learning and understanding machine learning. This series of modules basically covers your mathematical prerequisites to machine learning. And I'll tell you right at the outset, statistics covers 80% of that. So with that said, we'll begin studying the fundamental concepts of statistics. Now, right at the outset, you need to understand some important terminologies, first being the population. Now, I was mentioning a little while ago about sample and population. Now, in general, the entire data set that you have is called the population. And your population data set will have certain variables, which is one of the characteristics of the population. Now, this word variable is sometimes referred to as features. More often than not, it is described as features because they describe that particular population set or they describe that particular data set. So, if I had to take a fundamental example to explain you what a population or and what a variable means, I will explain it like this. Let us say, for example, I have a data set which consists of the performance of students in the first semester of their examination. Now, I have a data set like this. This is a rough data set I'm taking. First of all, I have the name of the candidate. Next, I have their university ID. Then I have their score in subject 1. Similarly, I have score in subject 2 and score in subject 3. And let's just say my final column is a cumulative grade. Okay. So this is how a student data set is represented. All of these columns that you see, university ID, score, score in exam 1, score in exam 2, score in exam 3, these are called the variables or feature of a population set because these describe your data, right? Or they tell you something about the data, which is why they are called variables or features. And your population is the complete data set. Now let's move on and let's look a little closer to what essentially variables are. We'll have a closer look at them. Now, variables are predominantly of two types. We have quantitative variables and we have qualitative variables. Another way to describe these variables are numeric and categorical. So here, if you see name, university ID, these can be more or less classified as categorical variables, and your scores are predominantly numerical variables. Cumulative grade can be also taken as a qualitative or categorical variable, or it can be taken as a numerical variable based on how the grading system works. Now, some more examples of quantitative. First of all, we'll discuss quantitative, then we'll move on to qualitative. Now, quantitative, as the name suggests, and as I've given you an example, whenever your data type is numerical in nature, that is when we refer to it as quantitative data type. Now, it has two further subcategories. It can either be a continuous or a discrete type. An example of a continuous numeric data type is something that can be measured. Let's just say, for example, temperature on a certain day. It's a measurable entity, and the because of the fact that it varies in a given range, that makes the nature of the variable continuous. Other examples of continuous numeric data types could be, let's see, apart from temperatures, you can have height of people, you can have weight of individuals. All of these characteristics broadly fall under the continuous numeric data type. Moving on, we have something called as a discrete. You have discrete numeric quantitative data type. Now, this is something. Now, discrete is something which can be counted. Let's just put it that way. That if your let's just say, for example, if we want to count the number of pets in each house, that is something which we need to go and count. So house one may have 5 pets, house two may have 10 pets, house three, 25 pets. So when it comes to discrete, it the data doesn't fall under a specific range, and it can vary at different locations. That is the predominant difference between continuous and discrete. Continuous falls under a specific range. Temperature, height, weight, all of these quantities, they fall under a specific range. With discrete, you the discrete data, the discrete numeric data type mostly deals with counting, and it does not fall under a specific range. That is the difference between continuous and discrete. Now we move on to qualitative data types. Qualitative is usually categorical. Now, qualitative has two types, nominal and ordinal. Now, the fundamental difference between nominal and ordinal is that for nominal, your categorical data doesn't have any labels. Now, for example, if I say that what if I say the color of an apple, it or and let's just say that the data I have apples of three distinct colors. I have yellow apples, I have red apples, and I have orange apples. Now, these three categories in and of themselves do not have levels, or they do not fall under a specific ranking system. Now, what do I mean by that will be more clear once I explain what ordinal categorical data type is. Now, for example, if I'm taking the performance of a student and I say there are 5 categories: outstanding, very good, good, average, below average. Now, these 5 categories, although they are categorical in nature, but they have an implicit ranking system, because the person who is an outstanding student is higher in rank than someone who is an average student. So, ordinal categorical data has a implicit ranking system in and of itself. So, I hope you understood the difference between continuous numeric variable and discrete numeric variable, and between nominal categorical variable and ordinal categorical variable. We'll move forward and we'll look at how some of the properties of quantitative data, and how do we study quantitative data when it comes to statistics. So for quantitative data, there are certain terms which I want all of you all to familiarize yourself with. Most of you all will be knowing this. And also a caveat, we'll be doing a lot of these functionalities in R. So I'll be explaining what all these terms are, but fundamentally every time we won't be going and calculating these things manually, because our objective is to understand the basic concepts of machine learning, not to do, let's just say, a detailed course in statistics. No, we just need to brush up our statistical concepts. So a lot of these functionalities will be done using R. So first term is mean. Now a lot of you might know this. I'll repeat anyhow. Mean is nothing but the average. If you have a data set which a numerical data type, and you have been given a set of values, the average of that that list of numerical variable that numerical those the average of those numerical values turns out to be the mean. So a good example will be, I have this variable called earrings. I'll just expand this so that it's clearly visible. So I have this earrings data set. It has 35, 40, 45, 33, 30. These are observations of this earring variable. Now, this data type is called a vector. For those of you who are familiar with R will know what a vector is. I'll not be explaining that once again. So if you sort this particular data, you will get these observations in ascending order. Now, why do we actually sort this? You will come to know the benefit of sorting later on. But for now, if you need to calculate the mean of all these values, in R, it's very simple. You pass the vector to the mean function, it will give you the mean. But mathematically, what mean is, if I need to explain using mathematical terms, so I will say x bar is equal to x1 plus x2 plus all the way, if I have n observations, xn whole divided by n. This is my mean or average. The next term is median. Now you will understand the importance of sorting the data in ascending order. Now median is fundamentally the middle value. Now if again I consider the same earrings data set, I run the median function and it returns me the value 33. Now with median, if the number of observations are odd, then it's very easy to find out the middle observation. Because right now I have 9 observations. So the middle value will be 9 plus 1 by 2, which is the fifth observation. So which is why we get 33 as the median. But if the number of observations are even, then it's the average of the two middle values, n by 2 and n plus 1 by 2. Sorry, n by 2 and n by 2 plus 1. These are the two middle values. You average the two and then you will get your median for observations, which if the number of observations are even. Now we have gone through mean, we have gone through median. Now we look at variance and standard deviation. We'll just remove this. Now, both variance and standard deviation are a quantifiable measure of how far the observations are from the mean. So again, if I have a data set which has n observations, x1, x2, x3, all the way till xn, and if I have to calculate the variance of the observations, then I'll go with the basic summation. Your I ranges from 1 all the way till n. You have xi minus x bar whole square divided by n minus 1. This is nothing but your variance. So again, as I was telling you, it's variance and standard deviation both are measures of how far your observations lie in the peripheries of the mean or in a certain range of the mean. To get useful knowledge of that, you study the variance and standard deviation. Now, standard deviation is nothing but square root of variance. Coming back to my example, if I want to calculate the variance of this particular earrings data observation set, I'll pass it to the var function. And if I want to calculate the standard deviation, I'll do the same thing. If you closely look at it, standard deviation is the square root of variance. Now we'll come to quartiles. Quartiles are also important when if we want to, or when we study box plots. So essentially what quartiles are is, quartiles tell you the number of observations that are behind a certain observation. The concept is very similar to that of percentiles. Go back to the days where you were given your mark sheet. You were given your absolute percentage, that is the marks that you have scored in the exam, but you were also given percentiles. What percentiles tell you is how far ahead or how far behind you are with respect to your competition. And your percentile is a reflection of the number of students which are there in your class amongst your competition and where you lie in that class. That is what percentiles tell you. This same concept is very key when it comes to statistics, and the same concept is reflected in quartiles. Now, essentially, when we study quartiles, we are concerned with, I would say, three distinct set of quartiles: the 25th, the 50th, and the 75th. We call them quartile 1, quartile 2, and quartile 3 in box plot, which I'll come to very soon. But essentially, the basic concept revolves around this, that if I look at a quartile function, if I look at the quantile function, and if I run this, and if you look at it, you have your 25th percentile, you have your 50th percentile, your 75th percentile, and your 100th percentile. Now, let us try and understand from the data, from this particular data set, how we got this result in the first place. This is also where you will really understand why arranging your data in ascending order makes a lot of sense here. First of all, if you look at this particular data set, you you have understood that 33 is your median because it's the central value. Now, if something is at the center, 50% of data lies ahead of it and 50% of data lies behind it. That is the concept of a median. It's the central value. So clearly from this data set, 33 becomes your 50th percentile or 50th quartile, because 50% of data lies behind 33. Now, if we look at the 25th percentile and the 75th percentile, now behind 33, which is the 50th percentile, you have these four data: 25, 30, 32, and 32. Now, if you look at the central value of this particular, only this particular set of data, which is behind 33, you will see that we have two central values, 30 and 32. Now, if you add those up and if you take the average of that, it will come out to be 31. But your R shows that it's 32. Now, this is fundamentally something that is, I would say, a fault in R, that the quantile function really does not accurately show you your 25th percentile. Again, that is the same with summary if you run summary as well. But essentially, the answer of the 25th percentile should be 31 because that is the middle value of 30 and 32. But since 31 is not in the data set, that is why it picks up the data that is higher than the 2. In the 25th percentile, in the 75th percentile, it did exactly the opposite because if you look at the data set on the right hand side of the median, 35, 40, 42, 45, if you look at the middle value, it comes out to be 41, but it picked up 40, which is the lower end of the two. So this is the fundamental concept of quartiles. They basically tell you how far ahead your data point is, or to paraphrase it, the amount of data that lies behind that particular data point. That is what is given by quartiles.